Hello students, welcome to Vision Institute. Today the topic that we will be discussing is friction. So as you all know, friction is a force that opposes the motion of a body which is sliding over another object. We face difficulties in pushing a body when it is kept on the ground. Okay, so the reason we face difficulty is because of something called friction force. This we will see with an example. Let's imagine there is a person who is trying to move this block, okay, and let's say the minimum force required to move this block is 61 Newton. For example, if you apply 61 Newton, then this block moves. So let's see, if this person applies a force of 5 Newton, then the block will not move. Yes, or I can say this person is applying a force of 5 Newton. Similarly, the ground is applying a frictional force of 5 Newton, but in the opposite direction, and this may be the reason why the block is not moving. We can consider that. Okay, so we can write that the frictional force provided by the ground on this block is again 5 Newton. Similarly, if this person applies 10 Newton force, the block still doesn't move, so the acceleration is 0. Then we can also say that the frictional force provided by the ground is again 10 Newton. Since the two forces are equal and opposite in direction, that is the reason the block is still not moving. Let's say now this person applied a force of 60 Newton. So we know what is the minimum force required, 61. But this person has applied 60 Newton force only. So it would be observed that the body still doesn't move. And therefore, we can say that the friction force is again 10 Newton. Now, this person applies 61 Newton force. And let's say this time the block has started to move. For example, let's say the block has started to move with an acceleration of 0.5 meter per second square. Then, why is the block moving? The reason is this person has applied enough force, and now the friction force value will be less. For example, let's take it 58 Newton. Because the opposite force is less, the applied force is more. This is the reason why this block is moving. If you want to get a feeling of this, imagine you are watching a tug of war match. There are 10 people on both sides, 10 people on one side, on side A, and 10 people on side B. So if all those 10 people have the same amount of energy, they are pulling with the equal number of forces, then you would see that the rope or the indication that shows which party is winning will not move. Now let's say on side A there is another person who came in, and now there are 11 persons in total. So now it is very obvious that side A will win. The reason? Because this force applied by side A is more than the force applied by side B. And so this can be seen here as well. The friction force applied is less than the applied force, due to which the body has started to move. Again, when this person increases his force, for example, let's say it is 80 Newton, the body will move faster because the force is more now. So let's say it is 2 meter per second square acceleration, and experimentally it has been observed that the friction force applied when the body has started to move is still the same. And now when this person stops applying force on this block, there is acceleration, but then the block has now started to slow down, and therefore we would see that there is a negative acceleration of, let's say, 3 meter per second square. But still here the frictional force applied by the ground would be 58 Newton. So we observe a certain force of frictional force here, certain pattern of frictional force here. What do you see? In this part, the frictional force is constantly changing, and it depends upon the applied force. How much applied force? The same amount of frictional force is here. What is the applied force? The same amount of frictional force is here. So what can we say from here? I can say that the frictional force here is variable, okay, and it varies on the applied force, and it is equal to the amount of the applied force. So every time you apply a certain amount of force, the ground exerts a frictional force of that same quantity. Now when this body has started to move, what do you see? The frictional force provided is a constant. Okay, so this frictional force applied by the ground when the body is not moving is known as static friction. And this force, frictional force, which the ground applies when the body is already moving, this is known as kinetic friction. The static friction is denoted by Fs. The kinetic friction is denoted by Fk. We also have one observation here. You see this force which is there in the static friction, this is the force beyond which the body starts to slide. So this force is a value of static friction, but this is the maximum value of static friction. So beyond this maximum value of static friction, if the applied force is more than this value, then the body will start to move. This Fs max is known as limiting friction. The formula for Fs max is mu Sn, sorry. The formula for Fk is mu Kn, and Fs, I'll write it here, I believe it would be visible. Fs, that is the static friction, has no formula. We find it by applying Newton's second law, and I'll write it over here. Just give me a minute. Fs max, the formula is mu Sn. Fk, the formula is mu K. So students, I hope that you were able to understand what exactly is friction, what exactly is static friction, kinetic friction, and what is Fs max. I hope this helps in your studies. See you in the next video. Thank you.